Okay, I'm going to start off where the last one finished. And you can see that we have the x values here and the z values that correspond with them. Well, those are easy as long as you have just nice, even round numbers for your mean and your standard deviation, which doesn't always happen. So we have a formula that allows us to convert any x value into a z value using this formula. So no matter what your mean and standard deviation look like, no matter what your data looks like, we're able to convert any value into a z value using this formula. Z equals x, the number you want to convert, minus the mean divided by the standard deviation. Okay, so for example, if I wanted to know something about 105, which is right in here, okay, I can convert 105 into a z value and be able to see the z value that corresponds with it. Because of those probabilities before, we're able to find out what the probability is of all these different z values because of the empirical rule. So for this example, if I want to convert 105 into a z value, I'll say the number I want to convert minus the mean divided by the standard deviation, which would give me 0.5. So 105 has a z value of 0.5. Okay. Now once we know the z value, there's a table in your book that will calculate, that will give us the probabilities of any z value. Now the table always will read and give you the amount that the probability of being less than that particular number. So if I go look up the z value of 0.5, that is going to give me the probability of being less than 0.5. So that would give me all of this area. Now the whole entire table is 100%. And we know that if you go at your mean, 50% are going to fall above your mean, 50% are going to fall below your mean because of the way that it's normally distributed, meaning it's symmetrical. Everything to the right of the mean looks just like everything to the left of the mean. So 50% of your values are above the mean and 50% of the values are below the mean. So that's a 50% chance of being greater than the mean, a 50% chance of being less than the mean. So we can take any z value, which now we're going to take this 0.5, and we can find the probability by using the table of being less than that particular z value. So the way this problem would have looked if we had drawn it out from the beginning, it would have said, what's the probability that x is less than 105? And our first step would have been to take this exact same problem and convert anywhere it has x, turn that into a z, and when we converted our x into a z, we got 0.5. So the problem would have looked like this, where the probability that z is less than 0.5, which is this area here. Then you'll go to the front of your book, and there's a table at the very front 2 pages. The table to the right is for positive numbers. The table to the left is for negative numbers. So this is a positive 0.5. So I'm just going to kind of try to show you here. Here is how you read the table. Here's the z value. And if it is 0.50, you go right here. If it had been 0.51, you would have gone here. If it had been 0.52, you would have gone here. 0.53. So this column just tells you the second decimal place. This is your first one. So 0.50. So the probability of being less than 0.50 is 69.15%. 0.6915. Okay, so we know that this probability right here is 0.6915. So that's how you find the probability of being less than any particular value. So on the next video, I'll show you how to do greater than and between, the probability of being greater than or between different values as well.